Welcome to Pump Flo training put on by Price Pump. Today's short training will cover all aspects of Pump Flo. Today we are going to start on the landing page after logging in. This is called the storefront. Here are the three main sections: AOD, close coupled centrifugal, and magnetic drive centrifugal. Close coupled and magnetic drive have the same program, so we will only demo one today. Additionally, at the top of the screen, there are 50 and 60 Hz buttons. This is used to set the base RPM in the centrifugal fields. More on that later. Now let's get started. This page is called the criteria page. This page helps us determine the pump we need for our application. The criteria page is broken into 5 boxes: rated design point, operating points, fluid and NPSH, types and speeds, and motors. Additional information and resources are available at the top of the screens. The basic information needed to select a pump curve can be found in the rated design point box. The minimum parameters are flow and head, but near miss is extremely helpful, as it is explained a little later in this video. Here you can change the units by selecting the drop-down next to the field. This is available in both flow rate and total head fields. Another option is to click the Change Units buttons. English and metric units are both available. The BEP field allows you to select which side of BEP you want to be on, and the near miss fields expands the selection criteria by a defined percentage, allowing you to select pumps even if they are a little above or below the rated BEP point. Let's go ahead and input 20% for our near miss, 100 gallons per minute for our flow rate, and 50 feet of head. If you knew your system's static head, we can input that there. This refers to the level of the fluid in the tank above the pump's center line. Next, we are going to look at the operating points box. Here we can adjust the default flow points, define custom flow points, or specific custom flow, head and static points. The next section is my personal favorite. The fluid and the NPSH box allow you to define the fluid pumping through your system. As you can see, the default fluid is water at 60 degrees Fahrenheit. What makes this section so cool is that you are able to go in and change your fluid properties. So we will click the Change Fluids button and open the Fluid Properties menu. Here we can choose from a list of dozens of fluids, listed in alphabetical order by fluid type. This database stores all of our relevant fluid properties, and when you select a fluid, it will automatically update the fluid properties, such as density, specific gravity, viscosity, and vapor pressure. Let's select sulfuric acid and see how it changes. Notice how the fields automatically update when you adjust the temperature. They update again. If your fluid isn't on this list, you can create your own fluid and input all the properties as you see here. Additionally, we can add an MPSHA and a margin ratio to further define the system and narrow down the search. Next, the types and speed section allows you to only find curves related to a certain pump models. All of the models are listed here, as well as the standard RPM, which were defined by the 50 and 60 Hz buttons we selected in the storefront. To narrow it down, it's easy to select what models and speeds you want to search. If you want to search them all, either select them or don't click any. Also, in the Types and Speeds box, there is a Product Info button. By clicking this, Pump Flo will also show you general curves for product lines and speeds. You can select your pump type and it will display the family curve for that pump. Then you can change speeds and size when applicable. Here is an example of an XT pump. As you can see, there is a large family curve where we can select between the different sizes and speeds of the pump. The last section is the motor. The standard and enclosed fields are always the same. However, you can define sizing criteria by max design power, max overall power, power specifically at that point, or no motor at all. Before reviewing our selection list, the 3 buttons in the top left corner can further assist you with properly sizing a pump. Calculators show 3 different options, the first being multiple pump. Here you can input the information and you will auto-populate your flow and head fields in the rated design point box. Next is a total head calculation. Here you can choose from 4 options and create a basic system within the calculator. This will populate the static head field with your result. Last is the NPSHA calculator, and this will populate NPSHA in the fluid section. Advanced criteria allow for defining the preferred operating range. The pump limits include max temperature, horsepower, and max suction specified speed. And lastly, curve limits as defined by trim. Manual selection allows you to bypass all of the other pump models and just see what a pump curve looks like compared to your design point. As seen here, with the RC200 at 1800 RPM, we are way off from our design point. Manual selection is not recommended. Going back to the start, here we define our 3 basic fields and click the search button, and Pump Flo will populate a table off all of the pump curves that fit our application. As you see, there are quite a few that encompass this head and flow. The standard sorting criteria of this table is by efficiency. Each of these columns can be used to filter the results. While price is not one of the filterable fields, one of the easiest ways to filter based on price is by looking at the motor HP and the model numbers. There is no need to pick a JB 150 stainless steel when a CD 150 all iron will do the job just fine. Additionally, each curve has a vertical red line. This is the minimum recommended flow line. While we can still see select pumps that have a design point on or near the line, it is not recommended. We recommend selecting a curve where the design point lands in the middle of the curve. After selecting our CD150, we now see a pump page. The first thing you see on this page is the pump curve and the red arrow indicating the design point within the curve. Additionally, this page includes a flow box, data point box, motor box, and a graph settings box. Let's start there. Graph settings allow you to customize what you want to see on your graph. This includes the pump curve display type, optional curves, an additional display, and its axis options. We recommend the default settings. Now, in the pump section, we can start manipulating RPM and diameter to change our curve. As you can see, the 4.375 diameter is the closest to the data point without going under, and we actually do a pretty good job of hitting it. This is indicated by the dark line in the middle of the curve. You can toggle the RPM and diameter to see what it does to the curve and how the data point is affected. Here we increase the RPM and notice the curve shifts upward. Fit to design resets it back to the original design criteria. Now we increase the diameter and it also shifts the curve up. Then we reset it back to the original suggested design. The data point section shows what the actual performance would occur at the design point. Here we have 101 gallon per minute, head is at 50.8 feet, NPSHR is at 12.1, and the efficiency is at 56.9%. Additionally, the HP lies between the 2 and the 3 horsepower curves, meaning that in the motor section, we would have to size up to a 3 horsepower motor. Now at the top right of the screen, you see 3 buttons: constant speed, variable speed, and multiple pumps. This pump page defaults to the constant speeds, but you can select the others to get different curve information. Here we will input a few different RPMs on the variable speeds page and click redraw to show the pump curves all on one screen. This is very helpful with the VFDs. As you can see on the left, All of those speeds are now overlaid on the left-hand side and correctly labeled. Additionally, all of the graph displays information can be changed here as well. Constant speed brings us back to the default screen, so let's jump to multiple pumps. This allows us to see what happens when we put more than one pump together in either parallel or a series. Clicking Read Draw populates the graph, and we are able to see what happens when we combine the two pumps in parallel, and now again in the series. Notice how the curves shift, but the data point stays the same. Now let's get back to the default screen. I want to highlight the three fields in the top left corners of this page. Design notes show the design parameters and limits of the pumps as well. Here we have curve data and also a catalog data which allows things like temperatures and pressures and all the different limits and specified speeds. The next button is cost analysis. This opens a form with two different ways to evaluate costs and generate an ROI. The first focuses on energy cost and requires a resistance curve. Here you input all of the data and make sure your curve is selected and you're good to go. This is very helpful with VFDs. The life cycle cost is more of a traditional ROI calculator, as you can see here. Last is the print button. This gives you two options, pump curve and datasheet. Let's start with the curve. Here you can input your name and your company information, and this will display on the curve. As you can see here, we are now generating a pump curve for an application that we put together. Your information is in the bottom left corner as well as all the design criteria across the bottom. Our logo displays in the bottom right. Now when we go back to the click print again, we'll select datasheet. Here you are able to input your company information again as well as a notes field. Here we have our datasheet. As you can see in this comprehensive document containing all the information, including yours and ours, related to the pump application. We have the pump, the fluid, the pump limits, the motor, our search criteria, the duty point, and design. Information all displayed on a curve on the right side there. Across the bottom, we have additional performance points showing flow speeds, head, efficiency, power, and NPSHR. This document is a great document to share with your customers as it contains all the necessary information. With that, this concludes the training on our closed coupled centrifugal and magnetic drive centrifugal sections of Pump Flo. If you have any questions regarding Pump Flo, please reach out to our sales team as we are happy to assist. For those of you interested, let's check out the AOD module. This opens the criteria screen just like in centrifugal, but with a few minor differences. The calculators and manual selection buttons are the same, but advanced criteria will allow you to limit by solid size, air pressure, and air consumption. The rate design point field allows you to define your design point, still with customizable units. The types box filters for metallic or non-metallic pumps. The product info button will still open up a family of curves and can be sorted by AOD size and type, as seen here. Operating points acts the exact same way as the centrifugal one, allowing for more detailed design criteria. But once again, my favorite section is the fluid section. Here we have built in a chemical compatibility module that is even more robust than the centrifugal one. By selecting a fluid in the table on the left, the wetted parts and rated compatibility as seen in the key below. Please note that this is for reference only, and chemical compatibility should be independently verified on your own. Let's input some flow head and near miss numbers as well as its viscosity. I'm going to put in viscosity 1, even though it is nowhere near the viscosity of liquid propane, but for demonstration purposes, it works. Now, once we click our search, our selection list will be populated, again sortable by any column, but defaulting by size. Why don't we go ahead and select a 2-inch metallic AOD? This page should look familiar. We are back on the pump page. Here you see the pump information, the data point, the graph settings you can change, and in the top left corner you can see the design notes and the print buttons. Design note buttons shows all the different pump criteria, and the print button allows you to access your pump curve and data sheets. Let's fill out the data sheet here really quick and see how it differs. Now we can see this data sheet looks very similar to the centrifugal one. We have pump properties, fluid properties, pump limits, search criteria, duty point design curve, and the curve on the right hand side in yellow. Beneath that, there is the chemical compatibility information. And at the very bottom of the page, you can see the different performance points that include the flow, the head, and the air consumption. Going back to the top of the page, you can see that there is your company information that you will input as well as our logo. This concludes the training on the Pump Flo module for price pump AODs. We hope you have enjoyed this training, and if you have any questions, please reach out to our sales team as we are happy to assist.